In this presentation, we can discuss about passing arrays and structures to functions. We are revising the use of pointers. So pointers are mainly used for sharing big chunk of data or memory locations to different parts of the program. So that includes passing arguments to functions as well, which we're going to focus in this particular presentation. Basically, there are two methods to pass argument to a function. One is by value, another is by pointer. When we pass the argument by value, a copy of the variable is created and initialized on the stack. The callee, or the function which is being called, accesses new variable which is passed from the caller. All done by the compiler such that the variable creation and initialization is transparent to the programmer. Programmer is not doing any of these things. He is just calling the function. Same amount of the stack space is used as the size of the variable. The variable is copied to a newly created memory location. So there is a duplicate variable is created. Because of this reason, if the variable is very big or huge, like a structure, a lot of space is wasted plus the initialization time. So you have to create that variable, so memory is being used, and you have to initialize that variable. You have to copy the content of the original variable to the newly created variable. The second method is by pointer. In this case, we are passing the address to the variable to the callee from the caller. We are not passing a copy of the variable. The memory used always is size of a pointer, which is 4 byte in a 32-bit operating system. No replication of data on the stack or time spent on initializing the variable. This technique is mostly used for passing arrays and structures to functions. So this method can be used for passing any arguments which are more than 4 bytes. If the size of the argument is less than 4 bytes, it doesn't make much difference. In the case of passing argument by pointer, change of value from the callee is reflected on the caller, as both caller and callee access the same memory location. So caller has a memory location which is assigned on the stack, and it is sharing that address to the callee, or the function which is being called. So they share the same memory location. So if one edits, it will be reflected in the other. Now let's try to understand what is happening behind the scene when you call a function. So we have a function called fun2, and we are calling fun1 from it. We are passing an argument 10. So in this case, we have an argument here called a, and we are printing it here. An argument to a function is very much like a local variable to the callee. In this case, int a is like a local variable to this particular function. So there is a hidden statement like this in that program which we have seen. This line of code is potentially executed by the compiler before fun1 starts. So this has two implications. One is an integer amount of memory or integer sized memory is used from the stack, and that memory is initialized with 10. So this is what is happening when you do call by value. An additional variable is allocated on the stack and it is initialized. Now let's consider a very big structure like this. In this case, here in this allocation, this much memory is spent. Again, when you call function 1, another copy of this is created and passing into this function. So again, this much memory is utilized. Only if you look at the assembly this will be clear, because this is hidden from the programmer. Now let's see a demo. We'll try to understand passing by value and passing by pointer. So we have a program up here. We have two functions, fun1 and fun2. Fun1 takes an integer, fun2 takes a pointer to an integer. So in the case of fun2, we are passing the argument by pointer. In the case of fun1, we are passing the argument by value. So this is a syntax. So when you call fun1, you can just pass this particular variable 100. In this case, you have to pass the address of main. So we are passing the address. In the case of fun2, you are accessing this particular exact same memory location from here. So you have to use the star operator to dereference this particular pointer variable. Another difference is I am assigning 10 here and I am assigning 20 to the dereferenced address. So this is a new variable, but this is the same address as this. So this 100 will be changed by this assignment, but not by this, because this A is a different memory location than this. But this A is pointing to this particular memory location. So we have a printf. So we are expecting 100 to be printed in here. After that, I am calling fun2, and again I am printing the same variable. I'm expecting 20 as the output here. So we are getting the expected output here. Now let's try to understand the difference between passing by value and passing by pointer. So we have a very similar program here again, which we have seen in the slides. So we have a big structure and we are passing it like this. So this is passing by value. So all we're gonna look is the disassembly of this particular function. So I have a breakpoint up here and I'm gonna start debugging. I'm going to the disassembly. So we can see that there is a very big local variable is getting allocated here, ESP minus 708. So we are subtracting a very big value from ESP, which means that we are allocating a very big value. Another one you can see here, right here. So there are two variables are allocated, as you can see, and obviously there is the initialization going on here, which is again very costly instructions like rep moves. Basically an additional variable is created and initialized before calling the function. Now what we can do is we can modify the program with call by pointer. To modify this program to call by pointer, all I have to do is put an ampersand here to take the address instead of the value and put a star here. I need the address. I need the pointer variable which can hold this address. So in this case we can see one sub ESP708H. We cannot see anything else here. Also we cannot see any repetitive instructions. Rep movers is gone, so initialization time is saved. We are just directly calling the function here. We have one additional overhead happened here, which is the size of this pointer variable, just 4 bytes. So instead of 708 bytes, 4 bytes here. So I have copied the difference in a notepad just to make sure that things are clear. So this is the case of calling by value. So the optimizations are off in the release mode, plus GS is also off, just to see the assembly correctly. And this is a release build. So as I mentioned, there are two allocations here. One is that and one is this, and the initialization code, which is very expensive. In the case of call by pointer, we don't have any of this, so we have only one variable and the call instruction after pushing that address. So we are getting the address here and pushing it onto the stack, and we are adding ESP4 just to reverse this push. Now let's go back to the slides. So we have seen this demo and we have understood the difference between call by value and call by pointer. In some books it is mentioned call by a reference, but actually it is call by pointer. Reference is a little bit different. It is of C++ specific, I would say. It is exactly the same concept as call by pointer. So the solution to the problem which call by value has is do not pass the variable by value. Just give the address of the variable to the next function. So no duplication, same memory region is being used. So this is called call with pointer or address reference. So I have seen different terminology for this. The underlying idea is sharing the address of the variable. So we have seen the changes. So we have added a star and an ampersand. So these are the changes we did, ampersand and star. So we have seen this demo. So we have to remember a couple of points here. The memory location is shared as I mentioned. So if any of the function edit, that will be reflected in the other function. If the callee edit, it will be reflected in the caller. Now there is a related topic of discussion of returning the address of a local variable. Again, same sharing address, no duplication at all, same as before, but this is a disaster. When the function returns, the stack pointer will get decremented and the pointer will be pointing to the memory location below the stack pointer, which means that it is a junk value. If the stack is unwound, there is no point pointing below it. It can be used by any function. So the bottom line is never ever return an address of a local variable from the callee to the caller. We are allowed to pass caller to callee local variables, not from callee to caller. If you want to transfer something from callee to caller, return the value as value itself by making a copy on the caller stack, or use the memory allocation which is done by the caller and pass to the callee. So this can lead to stack corruption. If you try to return an address of a local variable from a function, it can lead to stack corruption. So if the stack is corrupted, it can be very difficult to debug. The most important information, which is the call stack, will be corrupted. So you'll have to manually build the call stack and see what's going on. Sometimes you won't be able to do that as well. Depends on the nature of the corruption. So local variable can be used only in a function or in its callees. Same problem in a different way. So we have a pointer up here which has scope outside this curly braces. This variable which has scope inside this curly braces, what we are doing? We are doing this assignment. We are taking the address of this variable which has lesser scope and assigning to this pointer which has scope outside this curly braces. So once we are outside this curly braces, we cannot access this pointer because this variable has gone out of scope. The stack pointer could be decremented. We will see this problem in a demo. So here we have a program. This program got a main up here, and it's calling a function called wrong fun. So if you go to wrong fun, it has a character array which is a local variable, and it is initializing that character array to this particular string. Everything looks good. Now what it is doing is it is returning that pointer. So returning this particular address, which is pointing to a local variable here. So this variable is local to wrong font, and it's returning that address. Once this particular function is over, the scope of this variable dies out and the stack pointer decrements. Now what we are doing, we are trying to do a printf here, whatever value is being returned. Then we are using the stack, then we are again printing it. So everything looks good. So let's see what is going to happen. So right now I have called wrong fun. My breakpoint is here. I have called wrong fun. So things looks good. So the char ptr has that correct string. This is my string from wrong fun. I'm going to return it to main. So that string is correctly displayed here. So now I'm going to call printf function with input as this particular string. I'm going to press F10. The string changed to something else, which means that printf has used the memory location on top of the stack and corrupted this variable. Printf is doing something wrong? No, we are doing wrong here. We are returning pointer to a local variable. So anything got printed? Nothing got printed. Now I'm using the stack. I'm trying to print it again. Now I got something. I got some junk values printed. So once again, what we are doing wrong here, we are returning the address to a local variable. We are keeping the address of a variable which has gone out of scope. That is a problem in this program. So this is the problem line. Now let's go back to the slides. Now we will see different syntaxes for passing arrays to functions. We have to remember two things always. Whenever we give an address to a memory location to any other part of the program, there is two associated information. One is the start address of that memory location. Another is size of that memory location. So if you are able to give these two information correctly to the function or any other part of the program, things are good. So all the syntaxes we're going to discuss now is going to be based on this particular principle. So in some cases, the size of the memory location pointed by the pointer is implicit. For example, in the case of an int star, it is 4 byte. Char star, it is 1 byte. Some cases it is not implicit. Say for example, in the case of a void star, which is returned by malloc. Size is mentioning in the parameters. We do not know what is the size of the void star, so we have to give that size explicitly. So these are the different syntaxes which we're going to discuss for single and two-dimensional arrays. We're going to see them in a demo. So let's consider the case of single dimensional array first. So single dimensional arrays are fairly straightforward. We have an array here and we are initializing it here, and as you can see, two functions being called with exactly same arguments, fun1 and fun2. All we are passing is the starting address of the array or the name of the array and size of the array. So now let's have a look at the implementation. So we have seen the calling part of it. Now let's see the implementation of fun1 and fun2. So fun1 and fun2 in this case is for passing single dimensional array. So this is how fun1 looks. This is again fairly straightforward. It is taking an integer pointer, and it is an integer which is a size, and all it is doing is dereferencing that up to 9 here. So this is again straightforward. We have seen this program before. This is a fairly new syntax for fun2. So this pretty much behaves exactly like this. In this case, I am using this particular syntax. This square bracket is more intuitive here. So it's all about syntax. You just have to remember the syntax. Nothing to understand much here. All we have to understand is somehow we have to get the address and the size. Now the case of two-dimensional arrays. So we have a 2D array here, 10, 20 dimensions, and we are initializing it here, and we are calling 3 functions. So there are 3 different methodologies. So in the first case, I am passing the pointer and the sizes here. 4 and 5 is exactly same in the calling part. Now let's look at the implementation. Fun3, which is the first invocation, in which we are taking an integer pointer and row and column. We are using the pointer arithmetic here, so this can be a little bit complicated if you are seeing it for the first time. I'm finding out the element using the pointer arithmetic. If you are new to this, I would recommend watch the presentation arrays and pointers. I have a nested for loop here. This will print the entire element. Fun4 and Fun5 is more interesting. So the syntax is this for Fun4. The access is just like ij, array ij. So just like accessing a two-dimensional array. So this is again just syntax. You have to remember it. So this 20 is mandatory. We have to pass that. Another way of doing the exact same thing is this. Access is again the same. So this part is same for both Fun4 and Fun5. The only difference is the syntax here. So to summarize, all these 5 syntaxes you have seen is revolving around the fact that the address and the size is to be passed to the function. The rest is all the syntax part of it. Some of the syntaxes are not very intuitive, so we have to get used to this syntax. In fact, there are more syntaxes to do the same thing, which is out of our scope of discussion. And let's go back to the slides. So we have seen this 5 syntaxes to pass single and two-dimensional arrays. And that's it. Thank you very much.